Welcome back, Math 2 peeps. This is Parallel Lines Part 2. So this is where we start using the angle relationships we started talking about in Part 1. All right, so let's get to it. All right, now everybody knows what parallel lines are, all right? These are lines that never intersect. And anytime you see this symbol, they're telling you those two lines are parallel. Now, two lines with any arrows on them that blah blah blah. Two lines with arrows on them determining that the two lines are parallel. So when I look at this line and I look at this line, if I told you these lines were parallel, you might see an arrow like this on both lines, and that's basically telling you they're parallel. If you have another set of lines in the diagram that are parallel to each other, you might see two arrows on those parallel lines. Okay, so remember, parallel lines are lines that never intersect. You have this symbol, and in a diagram, they're labeled with little arrows on them. So the first one is all about the alternate interior angle theorem. If a transversal intersects two parallel lines, then the alternate interior angles are congruent. So if I have this transversal intersecting these two parallel lines, what happens is these alternate interior angles end up being congruent. So from that diagram, I could say angle 3 is congruent to angle 6, and I could also say angle 4 is congruent to angle 5. Okay, so remember, these angles are congruent. Next, we have the same side interior angle theorem. And this says, if a transversal intersects two parallel lines, then the same side interior angles are supplementary, which means these add up to 180 degrees. So when I identify the same side interior angles here, I'm going to say angle 3 plus angle 5 will add up to 180. And I will say angle 4 and angle 6 will add up to 180. Okay? So you have to know that alternate interior angles are congruent, same side are supplementary. Now, in these diagrams, guys, if they look congruent, they are congruent or equal. If they don't look like they're congruent, they're most likely going to be supplementary or add up to 180. Now, alternate exterior angles, right? When I look at those, 1 and 8 are alternate exterior angles, 2 and 7 are alternate exterior angles, right? What do we know about those? If two parallel lines are cut by a transversal, T being the transversal, then these alternate exterior angles 1 and 8 would be congruent, and then these alternate exterior angles 2 and 7 would be congruent to each other. Okay, the only other ones they don't really talk about here that we need to know, right, is corresponding angles. Okay, so what we know is if we have corresponding angles, these are congruent when lines are parallel. So when I look at 1 and 5 in the diagram, angle 1 would be congruent to angle 5, angle 2 would be congruent to angle 6, angle 3 and 7, and then angle 4 would be congruent to angle 8. And that's because these are all corresponding angles. And if you look at the diagram, each pair of those corresponding angles look congruent, therefore they are congruent. So when I look at this, 80 degrees and angle 5, right? What can we say about these angles? We could say they are same side interior. And earlier, what did we say same side interior angles are when lines are parallel? So this arrow and this arrow tell me the lines are parallel. Well, we know same side interior angles are supplementary, which means they add up to 180. So angle 5 plus 80 must add up to 180. And if I go to solve for angle 5, I would subtract the 80, and angle 5 is equal to 100 degrees. All right. The next one, when I compare angle 8 and 42 degrees, relationship between these is they are alternate exterior angles. These arrows tell me these lines are parallel. What do we know about alternate exterior? They are congruent. Therefore, I know angle 8 right away is equal to 42 degrees. Next, the relationship between angle 2 and 145. If this is my transversal, I know they're on the same side of the transversal. 2 is interior, 145 degrees is exterior, which means these are corresponding angles. And what do we know about these when lines are parallel? We know they're congruent. So angle 2 would be equal to, would be equal to 145 degrees. Now, right away here, find the measure of angle PQR. If I trace PQR, I start at P, I travel to Q, then I go to R. And if I put an arc in the angle that yellow angle is eating, it would be that angle there. If I compare this angle here to this angle here, those angles are alternate interior angles. So angle PQR is going to equal 70 degrees. And the reason is if lines are parallel, then alternate interior angles are congruent. Okay? So anytime they ask you to justify your reason, which these all did, it should technically be in this if-then form, but I'm not going to be super picky right now. Okay, now when we get into the algebra part, don't make this harder than it needs to be. Right away, if I highlight this angle and this angle, what I notice is those are corresponding angles. What do I know about corresponding angles when lines are parallel? I know that corresponding angles are congruent. So right away, if these are congruent, what am I going to do with their measures? I'm going to set them equal to each other. So x plus 15 is equal to 125. Now how do I solve for x? Subtract the 15. X is equal to 110. Okay? Now the next one, when I compare these, what's the relationship between these two angles? Those are same side interior angles. What do we know about same side interior angles when lines are parallel? They are supplementary. Therefore, I know right away that these two angles are going to add up to 180 degrees. So x minus 2 plus 78 degrees will add up to 180. Now, I look here. These are on the same side of the equal sign, so I'm going to combine them as they are. So x plus 76 equals 180. That's because negative 2 plus 78 is 76. Now I'm going to go ahead and subtract 76, and x is equal to 104. Okay? Now this here, what you guys have to understand is this arrow and this arrow tell me that these lines are parallel. Now, if I put an arc in 5x, it touches this parallel line and this line. This touches the yellow line and this line also. Right away I know this is my transversal. If that's my transversal, that means these angles are on the same side of the transversal and they're both inside the two yellow lines. So these are same side interior angles, which means they are supplementary. So what do I know about these angles? They are going to add up to 180 degrees. And if I combine like terms, 9x equals 180, And when I divide by 9, x is equal to 20. Now, if I wanted to find the measure of each angle, all I would do is plug that back in. 5 times 20 is 100 degrees, and 4 times 20 is 80 degrees. What should these angles add up to? 180 degrees, which is what I get. Now this one here, right away if I look at this, I can find different angles. Now some people might find angle B first using this triangle, and I'm okay with that, right? But what I want you guys to see is right away if I look at angle A in this 65-degree angle, aren't they alternate interior angles, which is going to make this 65 degrees. Now angle C in this 40-degree angle, those are alternate interior angles, so C is going to be 40 degrees. Now, what do all three of these angles have to add up to? 180. So to find angle B, I would just do 180 minus 65 minus 40, right? Which is going to give me, what is that, 105? So 75 degrees. Okay. Now this is a tough one. If I highlight my parallel lines like such, then I'm going to go ahead, put an arc in angle X, right? And then I'm going to put an arc over here. The reason I chose this line is I have to use the parallel lines. So the arc I put in each angle should touch, right? Should touch the lines I'm using. So what type of angles do we see these are? Well, I recognize X and 70 degrees as being corresponding angles. And what are those? They are congruent. So X right away is 70 degrees. Now, what do all three of these angles have to add up to? 180. So to find Y, 180 minus 70 minus 50 is going to give you Y is equal to 180 minus 120, which is 60 degrees. Okay, so let's look at this one because I like this problem a lot. I have this parallel line, and I actually have two transversals, right? But I'm going to focus on this transversal right away. Now when I look here, there's really no correlation. If I use x and y, I can't solve for one variable. So somehow, some way, I have to use both of these y's. But if I look, they're on opposite sides of the transversal. One is interior, and the other is exterior. So what am I going to do? Well, what I'm going to do is I'm going to say this angle is congruent to this angle. So if that is y, I'm going to say this is y. Now, what do these two angles have to do? Those two angles have to add up to 180 degrees. So I'm going to go ahead and solve for y. Combine like terms, divide by 4, and y is equal to 45. Now, if I look, if y is 45 degrees, right, what do x and y have to add up to? 180 degrees. Or even better, what is 3 times 45? Right? That's going to be 135. And if I look, what do we know about this angle and this angle? They are congruent. So what is x going to be? X is going to be 135 degrees. Okay? So go ahead and try the homework. And if you have any questions, let me know.